Okay. Hello, everybody. My name is Lubomir, as Peter told, and let me on the beginning introduce Embraco company. I'm pretty sure that most of you knows Embraco very well. Embraco is a brand name of compressor manufacturing company, but recently in our life changed something. We become a member of big corporation NIDEC as one part of it. Uh, NIDEC is the company focused mainly on electrical motor manufacturing in the beginning when it was founded in 1973, but nowadays it has more than 330 companies included, placed in more than 40 countries, and has 1,200 100 to 120,000 employees worldwide. Headquarters is obviously in Japan, in Kyoto, and it's a very dynamic company which is growing day by day. And recently there were done over 60 mergers and acquisitions. It's a company which has operating profit about 1 billion of US dollars and turnover about 14.4 billion. Mr. Nagamori is the founder of that company and in the same person also chairman. NIDEC, it's a very big group, contains several businesses. So let me say that we are a part of global appliance branch, which has two headquarters. One is in Brazil and one in Italy. Has about 14 manufacturing plants and 4 business offices across 9 countries, 9 R&D and developing center with more than 600 engineers, and totally we have more than 15,000 employees. Annually, we produce over 65 million motors and compressors and serving more than 80 countries. NIDEC Global Appliance has 3 branches where are home appliances with home refrigerators, washing machines, dishwashers, and dryers. Then there is a commercial appliances with compressors and condensing units for refrigeration and cooling systems. And then is heating, ventilation, and air condition, where mostly contribute with motors, under group of US Motors and Rescue. Embraco products can be found in home appliances, as I told, commercial appliances, and also for aftermarket as a spare part for existing appliances. Our portfolio is very wide, and we are starting with 112 of horsepower up to 2 horsepower in reciprocating compressors, the hermetic ones, and then we continue up to 13 horsepower for scroll in fixed speed range. But we have also variable compressors, smaller size, mostly used in household and small commercial. And then there is a big line of different condensing units execution, starting with naked and finish with silent. And on the top of it, there is cooling systems, which means completely sealed unit, which contains evaporator, condenser, and everything charged already with refrigerant. It's enough to put it on the top of the cabinet and it can work. So we are focused on natural refrigerant with low GWP, which is trend nowadays. Focus on energy efficiency, high level, innovation mainly regarding this variable speed compressor and inverters, keeping very good reliability and high quality and performance. Where you can find our compressors. So we are serving to merchandisers, food service, food retail, and medicals in all range of our compressor, from smallest one to biggest one. Fixed speed, variable speed, and the condensing units is an option. So that's more or less Embraco. And now let's focus on main part of our presentation, talking a little bit about the most common failures which happens when applied compressor on the market, then how to select compressors, and on the end, when we buy new one and go to replace it, how to do that replacement step by step. Common compressors failures. I would say important is before we start to think about a replacement of compressor, we have to consider certain fact. During many years of working on quality, I did some statistics, and we can say that about 30% of rejected compressors to manufacturer for analysis are free of manufacturing defects. What it does means? It means that a guy who did a diagnostic of the system, he was too fast and decided compressor is a failed and rejected it back, but it was not the right decision because probably there was another error in the appliance which he did not discover. We should not blame him for that, because if you imagine how it works, he usually work on the market in cold place, not good lights there. He is lying on the floor, and behind him is standing out of this application, counting minutes, how long time it will take to repair it. So conditions for his work is really not very favorable, and it's very easy to commit mistake in such situation. But we have to take care about analysis and diagnostic of appliance itself, because it may happen that there is a problem on appliance, not on compressor. So we should check first refrigeration circuit to understand whether there are some leaks, whether motors on condenser and evaporator are running, whether condenser is dirty or not. Temperature sensor failure can appear, thermostat failure, which is quite common. Basically, have a look on the system at all to understand whether we see some anomalies. Then, a lot of time when serviceman reject compressor for analysis, he forget to reject electrical components because he is convinced that compressor was faulty, and he think, why I have to send overload protector or relay, who cares? But first of all, we have to check in appliance before disassembling compressor what types and models of electrical components are assembled on it, because it could be done some previous maintenance with other servicemen who change, for example, relay or capacitor, not correct one. So we have to check codes. If they are correct, then we have to verify them whether they are failed or not, because a lot of time fail compressor components itself. For example, start capacitor can be blown out, or overload protector can be blocked due to very frequent acting. So by simple exchanging of electrical component and compressor, we can solve the problem without disassembling compressor from appliance. And in, let's say, best case, when we come, an application is still able to work, but doesn't provide the required cooling capacity, then we can face another issues like condenser temperature is too low, evaporator is too high, suction temperature too high. Simply, there are some anomalies, and we have to understand what might be behind. And most frequently, it can be refrigerant leaks, capillary tube plugging, or even compressor internal defect and bypass. So based on this analysis, we should be convinced that when we are gonna to replace compressor, it's reasonable. Why? Because when we send compressor to manufacturer for analysis, there is certain procedure to analyze compressor, and we have to first measure it without opening compressor, trying to evaluate the basic parameters, electrical safety, and so on. And then we try to start it up. And when we start it up and it works and runs, we put it to calorimeter, we verify, we found out that there is no defect on that. So rejected compressor are lost money, because procedure is telling us that after first pre-analysis, we have to open compressor anyway and disassemble it component by component and check them properly, because by our experience, it might happen. It's very rare, but it might happen that on calorimeter compressor really runs and perform well, but when we disassemble it, we can find some defect inside. So without complete disassembling, it's impossible to take final statement. And once we disassemble it, compressor is lost and money are gone. So very important part. Now let's focus on some most common failure modes which we see on compressor rejected from the market. And let's talk a little bit about that, what's behind and what are possible root causes. So first of all, manipulation with compressor. It's storage and transportation. It's a sensitive thing, and in our instruction manual, you can find a table with recommended positions for transportation and handling, and also not recommended position. Why is that? Because you don't see what is in internal design of compressor, and if you put it in the wrong side, you can get oil inside of suction muffler. Then when you start it up, you can destroy valve and gasket. And also, when it is not in correct position during the transportation, by vibration of kit inside, it can generate a lot of residue. And later on, during running of compressor, the residue can block the filter dryer and can cause also a lot of damages inside. So that's very important thing to have clear in mind which family of compressor can be stored in what positions and manipulated. Blocked compressor. It happens time to time, and there might be several reasons for that. Of course, most common can be very high load on compressor during running, run without oil, liquid refrigerant inside the oil, dropped compressor, and contamination. So running without oil, it depending a lot of time on design of the system. If there are some traps inside of the system, and during running, compressor pump together with refrigerant also a small amount of oil, by time it can be collected inside of the system, and if not rejected back, then compressor run without oil and obviously will be damaged. When we have in the running of appliance situation where liquid refrigerant can come back to the compressor, it can mix with the oil, can be sucked in the lubrication system, and instead of oil will be in the bearing present a liquid refrigerant or bubbles, and this will for sure not properly lubricate compressor, and consequent damages will appear. When we drop compressor during manipulation, of course, there can be damage some mechanical part internally, and contamination is a special part. We can get contamination, as I mentioned, from wrong transportation and manipulation, but also from the system components, not only from compressor itself. We will mention it later on. Regarding overheated compressor, that's the chapter which obviously take place. In this case, we are meaning overheating due to pumping of the pump. It means overheating of the valve system itself, which consequently will influence also suction muffler and surrounding areas like a stator. So again, high compressor load, insufficient cooling of compressor. It means if we place compressor out of the reach of motor fan, so motor fan will run on the condenser, but not on the compressor itself, and will not cool it down. Again, in our instruction manual, there are written combination of position motor fan and compressor to assure good cooling. Sometimes happens that some customers do not install fan at all. And running outside of working envelope obviously can bring this risk of overheating. Also running without a refrigerant, because as surely you know, if there is a leakage and a refrigerant will escape and compressor will suck in the system air has completely different thermodynamic properties. So by compression of the air, we generate much more heat than by compression of the refrigerant itself. Compressor pump malfunction, that's an interesting chapter. It's related to many factors. Of course, high compressor load and running out of envelope. We can see on this left picture, we have to say these pictures are representing the most heavily damaged compressor, and there should be for sure some clear reason on the field in application. So here, when overheated discharge side, high temperature and pressure, you can see on discharge valve a lot of carbonized residues and colored discharge valve plate. So when we see that, it's clear for us that the work conditions were far away from normal, because when we open compressor, which was submitted to live test, which is on the limit of the envelope, usually we do not see such damaged valve plate, but it's nice clean. So that's the clear evidence of very heavy conditions. Here on this picture, you can see the cylinder head, valve plate, and support of the compressor. And here it's missing part of the gasket, which you can see here. Around the valve plate should be gasket, and in this part we see that is missing gasket. It's happening very frequently due to liquid return to the compressor. And you can get or a pure liquid refrigerant inside, or a mixture of liquid refrigerant with oil. Obviously, compressor is trying to compress it, but as we know, liquid is not possible to compress, and it will generate a very high discharge pressures inside of cylinder. Roughly saying, normally compressor works about 15 to 25 bars, and when we have liquid inside of cylinder and it's pressed by piston, it can generate over 200 bars pressure. So that's the natural consequence that we will destroy the gasket. Purity of refrigeration circuit, that's a nice chapter to talk about. First of all, you have to be sure from what source you are buying refrigerant itself, because you can find different sources on the market, and some are even fake, smuggled, and I don't know what. Sometimes even do not represent refrigerant which is written on the label. So we have to be very careful, but in best case, there could be liquid inside or uncompressible gases, which can bring situation like this, that will increase dramatically pressures in the cylinder and overheat motor. Then there are some components in refrigeration circuit. For example, if you buy some cheap filter dryer, Embraco recommend use only really very well-known brand names, because some cheap manufacturer put inside this micro sieve with not good quality, and during running it can be broken on small parts, some debris, which then will circulate in the circuit and can get inside of the compressor, can plug a filter dryer, and this will increase dramatically discharge pressure. There are also another residues in the circuit. I have to mention that, for example, evaporators manufacturer, if they do not follow manufacturing procedure, which normally should be as follows, that when they are welding tubes on evaporator, they have to fill internal volume by nitrogen to avoid oxidation of the copper. If they don't do that, for many reasons, they will generate copper oxide on internal surface of the evaporator, and then during running of compressor, by splashing by oil and liquid refrigerant, it will get back to the compressor and accumulate there, and can cause blockage of mechanical parts in bearings. Then by friction can destroy insulation on the stator, and in worst case it can sediment even on hermetic terminal fusite, and can cause some sparking and short circuit internally. Let me mention also tubes in the system. Sometimes people try to find cheap tubes, and instead of using copper, which is dedicated for refrigeration system, they use heating system copper tubes, which do not have required cleanliness and contain a lot of and release a lot of residues to the system. So there are several things to take care to avoid coming residues from the system. Burnet stator, yeah, of course, it's happening. And there are also some specific reasons behind. Usually when there is something not good with appliance and it's pushed to start frequently or start under heavy load conditions, it can fail in the start and start trip on overload protector. And by repeating that procedure very frequently and continuously, temperature of the compressor itself will grow up, and it will result to burning of the insulation on the stator. Power supply should be also in correct limits, because it happening time to time on the market that some customers plug more appliances on one power supply line, and by high current pulling from that line, it can happen that voltage will drop down and will be not sufficient for correct starting of compressor. And here I would like to stress some examples which I saw in practice. For example, long extension cords with small section of the cables will cause voltage drop, and compressor will not get 230 volts, but maybe only 180, which is not enough. So also not properly selected compressor. If we connect compressor which was not designed for this power supply line, it can happen that it will burn compressor. I have one very funny example. It's very important to build good trust between compressor manufacturer of appliance and final user, because a lot of time when we get compressor for analysis, it is not so easy to point out what was the root cause of the failure. We see symptoms, we see evidences, we can point out possible root causes, but to point out a true one, sometimes it's not easy. I will give you an example from United States. They have a kind of shop called Eat What You Can. So they placed ice cream servers in one room, about 10 appliances. Each one has 2 kilowatts input. And it worked in the style that stop bus with student, 40 students enter in and start to serve one by one from each machine, because each machine has a different ice cream, so they want to enjoy. And they push those machines, start very frequently, and all of them were connected to one power supply line. Obviously, it caused a dramatic drop of voltage, and some machines failed and burned stator. If final user would not share with us this situation, what were conditions on the market, we would never be able to say what is behind. Another example was from China. They put freezer for ice cream on the street. It's usual practice there to sell ice cream on the street. And in this region where some trees, I don't know in English language, but they release in certain seasons some like cottons, some residue, which fly with the air and block on the condenser. They completely close the condenser. Obviously, temperature raise up, pressure raise up, and consequently burn compressor. If manufacturer of appliance which was running there try to solve it, would not share with us this situation, we would never find it out. So trust and cooperation between manufacturers and user, it's very important for indicating root cause. Another part is electrical components failure. This is very interesting because, as I mentioned on the beginning, a lot of time customer reject only compressor thinking that electrical components are okay. And if we receive it without components, if failed components, we will never find it on compressor. We find symptoms of its failure, but not root cause. So always send components. Here on picture, you can see, for example, start capacitor. I don't know whether you had opened it already, but it looks like that inside. There are some leads leading to the coil of capacitor itself. By bad manipulation, shaking and so on, it can break the leads and will become interrupted, will not work at all. Coil itself, if capacitor is working in heavy conditions, will become overheated and will evaporate electrolyte out, will dry coil. Capacitor will lose its capacitance and compressor cannot start, and when it cannot start, repeating starting, and by these cycles will destroy completely start capacitor and consequently compressor also. By such situation, we can affect also overload protector, because you can see here one piece is completely burned contacts. If he is pushed to be actuated very frequently, then it will finish with damage, because normally it's designed to survive, let's say, manufacturer is proving 2000 cycles, let's say. By test, we know that will survive from 8,000 to 12,000 cycles, and then will die. So, or will stay with closed contact forever, or will disconnected contact forever. And it will affect us. If it is disconnected, it's not so big problem, because compressor doesn't run and guy will come and will try to find out what's going on. But once it's connected forever, it's very dangerous. because in situation where should disconnect, will not, and then will cause damage of compressor. Here on this picture, you can see exploded start capacitor. It can happen in the case that when it is in heavy work conditions and generate this evaporated electrolyte, increase pressure internally, there is a safety plug here which should release this pressure outside. If this doesn't work properly, then it can even explode like you will see here. So there are several kind of defects which you can find, and there are another on the starting relay. This is the picture of burned start relay, which by frequent starting and tripping can overheat contacts and fail. So electrical components for sure are components which we have to check as a first, and if they are wrong, replace them and only then look on the compressor itself. So once we arrive to conclusion that really compressor is the guilty and it's failed, we want to choose a new one. Of course, we are lucky guy if we for the same model from certain manufacturer will find the same model from the same manufacturer, then it should be okay and no problem at all. But if we cannot find that and we are looking for another manufacturer, then we have to pay big attention how we will choose this compressor to be sure that it's real equivalent. So here I put a list of some very important factors which we have to check one by one to be sure that we are choosing right compressor for substitution. Obviously, first of all, it has to be correct frequency. There are some compressors designed to work with both 50 and 60 Hertz, but there are some which not. You have to choose the right one. Then voltage power supply seems to be easy. Of course, everybody knows 230 volts, that's it. No, it's not so easy because if you look in our installation manual, in Embraco we have about roughly 15 different voltage combinations, I mean, regarding nominal voltage and its range. So we have to be sure for which territory we want to apply this compressor and choose the right voltage range. And then look also what is the voltage range for running of compressor and voltage range in which we guarantee that will compressor start up. Refrigerant, that's a special chapter. There are a lot of guys who are making experiments, and in compressor for 404 refrigerant, they apply 407C and so on. And there are even worse examples. So it's really not recommended to use different refrigerant. Yes, by design, some models are multi-refrigerant design. Yes, it's true. And in such case, it's possible. But if it is single refrigerant design, we have to follow recommendation of manufacturer. Application type. Yes, a lot of customers decide to buy LBP compressor and apply it in M or HBP appliance. Why? Because LBP compressor is designed for not so big load, has a more weak stator, I mean electrical motor, there is less of copper, and obviously this costs less. So it's cheap compressor, and they enjoy to buy it and apply it here. But compressor designed for HBP conditions, they have completely different electrical motor with much more copper. That's why it's more costly, but it survive also heavy conditions. So we have to pay attention, do not mix kind of application each other. Starting torque, yes, of course, we have some control element, capillary tubular expansion valve, so we have to take care whether compressor we choose is low starting torque or high starting torque. If we choose low starting torque and there is expansion valve, for sure we will face the issue. Motor type, yes, here is, I think, complete list of executions which we have in Embraco portfolio, and you have to understand what was there before and choose the same execution if possible. But choose execution, for example, here we see it's starting capacitor and not running. Here it's starting and also running. So why I have to choose this and when, and why I have to choose this and when? Easy. This one, without start capacitor, can be used on appliances where it's easy conditions for compressor to start. So it will work, no doubts. If I'm looking for a version which has higher efficiency, I should choose one which has start run capacitor. If I choose this one, where are heavy starting conditions, I will put start capacitor in. But if I want to reach higher efficiency level, I should put version where is also run capacitor. So important to choose properly. But if I will choose, for example, this one, where it's starting device and start capacitor, we have to think about starting device. It's not so easy to understand on which application, which starting device should be pointed out. So for example, PTC, for very cheap compressor, PTC is very cheap starting device and it works. In household, it's very good because there are light starting conditions and it's enough to study that. But we have to keep in mind that PTC keeps starting winding connected only for 0.3 seconds, maximum 0.5, and then will disconnect independently whether compressor 60 to start or not. So if there are more heavy conditions, we have to put, for example, TSD, time starting device, which is very similar to PTC, but there is electrical board which control time and prolong it. So here we'll keep starting winding connected from 0.8 seconds to 1.2 seconds. So if compressor has difficulties to start, with this device has bigger chance to start. And then there are compressors which use current and voltage starting relay. And in very heavy conditions, it's recommended to use this alternative because current relay will keep start winding connected as long as necessary for compressor to reach nominal speed. So even if conditions are difficult, we have high chance that compressor will succeed to start. So very sensitive what we choose. Cooling type, you know, there are compressors for household which are static. In household, in fact, is not desired to have motor fan because motor fan in most of cases is most noisy component in the refrigeration circuit. So having in household applications, it would be disaster. But in commercial, we have to use motor fan. Again, in our instruction manual, there is a picture showing what should be correct position motor fan against the compressor to blow air on the compressor and cool it down. And if it is recommended use with fan, we have to put fan there. Otherwise, we are risking overheating of compressor. Cooling capacity. Yes, we have to choose compressor according to cooling capacity. First step is to choose by rating point, but then we have to choose also working conditions point because in new design of compressor, it might happen that we have two compressors which in checkpoint, in rating point, they have the same cooling capacity, but when we check it in system working conditions, we will find out that one is performing better than the other one. So in the past, customer used to choose according to displacement. And I have to say also today, I use this approach for first step, for approximation. So, okay, if I had 19 cubic centimeter compressor, I will go for 19 cubic, choose one, but then I have to go to the rating point in watts and then to the working point in watts to be sure that the really cooling capacity will be sufficient. Ambient, no discussion. You know that applications are designed for different ambient and climate classes. So if you want to sell it somewhere in Middle East, we need to have tropical or even subtropical compressor. And what's good for tropical conditions, which means ambient plus 43 degrees Celsius. And we have several models designed especially for those heavy regions like Middle East and Africa, where we have approved it in super tropical plus 48 Celsius. So right choice is a good choice. Running conditions, if we are saying here that we should check cooling capacity in working conditions, so it's good to know what are working conditions, what is evaporating, what is condensing, suction gas, and liquid temperature, to be sure that what we are choosing will work in these conditions. here I would recommend, it's good to have measured pressures in application to understand what are a real evaporation and condensing temperature, because if we have, of course, a connection to connect manometers, because if we are only measuring by thermocouples, we can commit quite big mistakes in the temperature. So more or less, that's it. Then there are some points which seems to be not important, but on the end of the story can be very important, like the dimensions of compressor itself, base plate, tube size, height of the compressor, and so on. Then we need to understand whether we need to have connector adapted for rotalock, or whether we need fixation for evaporation tray, and so on. So there are several points to focus on when we are choosing. And then there is another level, you know, that we are coming to the period where becoming very interesting compressor with variable capacity. So let's talk a little bit about inverters itself. First of all, when you look on compressor, so usually we obviously find out that it's only on-off compressor, or there is a compressor with some electronic box, which most probably is an inverter. In such case, we are talking about variable capacity technology, and we have to understand what this inverter is. In Embraco, we have three main control modes for inverter. One is drop-in, another one is frequency, and third one is serial. Each one is used for certain kind of appliances and customers. So we have to understand what is used there and use the same option. Drop-in usually is able to work with mechanical thermostat and doesn't need any electronic controller, which is most simple solution, and we have that in portfolio. So you will simply disassemble on-off compressor, and you can assemble variable capacity compressor with this drop-in inverter, connect their mechanical thermostat, and it will work. It's a miracle. Then there is a frequency control mode where you need already electronic controller, because here compressor is driven based on command from this controller. Compressor is only slave and doing what he got as an instruction from inverter. And then there is a serial version, which is used mostly by household manufacturer, because they build by themselves some electronic control board, and they use two-way communication with compressor inverter. So there is a special case. Thermostat type, as I mentioned it, in some simple appliances with mechanical thermostat, and in some electronic, and depends what inverter you choose, you have to choose also proper thermostat types. PFC, it's a power factor correction. Now we have to understand whether in the region where we are applying compressor, it's required to fulfill these conditions. And if yes, then we have to choose inverter which has this function. Then there is another issue which we call electromagnetic compatibility. Here we are talking only about the inverter, but as we know, final manufacturer has comply with whole appliance for this electromagnetic compatibility, but frequently he is asking also for inverter to be compliant with this requirement. There might be also some special routine in the software of this inverter. There might be compressor which has on certain frequencies some resonance on the components. So inverter has to be built in the way to overjump these critical frequencies to avoid destroying of compressor. So it's not recommended to take compressor from one manufacturer and choose some other inverter and put them together, because then it can become in conflict and can destroy compressor. Connector types, of course, inverter has several connectors, so you have to have a cables which has the same connectors to be able even to connect it. And mechanical execution, there are some options like connected inverter directly on the compressor hermetic fusite, or fix it standing alone, or fix it on the wall of appliance. And the last requirements can be related to IP protection, because some appliances are not placed inside of the building but used also outside, so it can be submitted to some rain conditions, or even inside of the building sometimes can be in the area where can be dropping some liquid from the top. So we have to understand what are real requirements for IP protection. So let's imagine that we decide based on our diagnostic and analysis that the really compressor is failed one. We rejected it to manufacturer and we bought new one which came to us in nice carton box with pink strip on it. We open it anxiously, taking it out and trying to apply it in appliance. What might happen if we forgot for something on previous steps? So I take compressor, try to put it in, oops, I see that base plate has different dimensions between mounting holes. What to do? Okay, I will drill another hose to fix it up. Then I take electrical box, the same story, not matching holes. So what to do? Let's adapt it somehow. Take a cable and connect it to, it's short cable, my goodness. So I have to prolong cables, another activity. Let's connect tubes. Tubes didn't fit because compressor has a different dimension than tube in my system. I have to enlarge it. So there are several steps which could fail, and it can happen even that we choose different manufacturer which has a different size. I mean, height of compressor and dimensions. So it cannot fit physically inside of appliance on the end of the story. And I would mention also very important point, which I forgot to mention before, that usually there is some convention that on the left side is a process tube, on the right side is the suction, and then on the top is the discharge. But on some models, it can be exchanged, or even some manufacturer can use opposite direction. So suction tube and process tube can be on opposite side. If we are running under routine conditions and we, let's say, think that the process is on the left side and we connect there the tube for charging of compressor and we will inject liquid refrigerant there and it was not process but suction, we can destroy compressor in this way. So we have to pay attention also for description. Usually on compressor label is indicated which tube is suction, which process. And if not, let's go to the website, to the manual, and be sure to connect it properly. So we are ready to exchange compressor in appliance, and I will move this presentation to the step where my colleague Libor Novak, which is very skilled technician, specialist from application lab, will tell you a few words how step by step remove compressor from appliance and put new one, charge it and let it run. Libor, it's your turn.
Thank you, Libor. Let's switch the screen. Okay, I hope that can you see my screen.
Yes, we can, Libor. Go ahead.
Okay, great. So Libor let me 14 minutes. So it will be very quick. First part of my presentation should be an algorithm, and second part should be a step-by-step procedure. So I decide to skip algorithm and let's go step by step, where I would like explain to you each operation which is necessary perform during compressor replacement. I will speak quicker because we do not have a lot of time. So, as a first thing, please always, if you are starting a repair the system, switch off it from electricity. Yes, it is for your personal protection. And I would like to add one point between the switch off the system and clean the condenser. Please, if you came somewhere on the place where you have planned service action, please inspect the system, revise the system. You need to know as a service technician what are you fixing, in fact. Then, next step, please clean the condenser and compressor place from dust. It is also very important because during years of operation of the system, dust and dirt will be everywhere. And why do not make your job more comfortable? Yes, you don't need to work at the dirt, so that's great. Do it as a third step. Next step, please disconnect electrical components from original compressor and check the refrigeration circuit. If there is not installed any valve or some element which can block the gas recovery. As you know, compressor is broken, so you are sure that you are going to replace it. So it is the first part. Mainly if the systems are bigger, multi-evaporator systems, more complicated systems, there will be 100% installed some valves which can block your gas recovery, and it could create a problem. So if there are some solenoid valves, please install the magnets and open those solenoid valves. Also, you can connect solenoid valves to electricity, but only solenoid valves, no system, no complete system. Or you have third options. You can the lead valve closed, but you need recovery or release the gas from low and high pressure side. As you know, HFC's refrigerant as 134A, 404A must be recovered to pressure vessel. Hydrocarbons refrigerant as isobutane or propane can be released to the atmosphere. But if you decide release it, please do it on open space, because as you know, they are flammable. Be careful because its density is higher than density of the air, of the atmosphere. So they will stay always somewhere down at the holes and on the ground. So be careful and let those refrigerant flow somewhere in the open space. It's highly recommended. After gas recovery, we have in fact two possibilities what to do. If the gas is released or recovery, connect vacuum pump for 20 minutes. If there was hydrocarbon refrigerant, from 40 to 60 minutes. Second option is to flush refrigeration circuit with nitrogen. Mainly is recommended with hydrocarbon refrigerant. Why to do this activity? During a soldering process, and soldering of system tubes where has been hot refrigerant, you will always have presented fire, because as you know, refrigerant is mixed with the oil. So always some refrigerant stay at the oil. So you have two options: make a vacuum or flush the system with nitrogen. If you made it, disconnect vacuum pump and equalize circuit internal pressure to atmospheric pressure. It is also very important. Please never solder system under pressure. Yes. So now you can unsolder compressor. Yes. If tubes are long enough, it's better way to cut the tubes very close to all compressor. And in fact, it is better solution, because you will have immediately prepared the tubes for soldering on the new compressors. That's great. Now you can disassemble compressor, release the support, and remove old compressor. Also, please disassembly or cut old filter dryer. So old compressor is out. And now, what to do with the new compressor? Please take a box, unpack new compressor, and package must contain compressor, electrical components, grommets, and sleeves. Please check all components for damage. Yes, if there is observed any damage on the compressor itself, on the tubes, something is not. Something look as the compressor fall somewhere, has been its handling has been bad. Rather, send the compressor back to the distributor and ask for a new piece. Yes, please do not use it. Of course, you can, but you are risking that you will perform this compressor replacement again, and it will cost money and time for you. So, install new grommets and sleeves to a new compressor, and assembly compressor to a refrigeration system. Check the handbook or catalog position of discharge suction as service tube. It really depends by compressor family, and compressor handbook or compressor catalog you should have always with you during a service action. Why it is important? Because suction line and service line or process line in the past has been equivalent, but today with the new model it is not true. Many of our compressors have direct suction, and if you change the position of the tube, you can also affect compressor cooling power, and an effect is its performance. So please be careful. Always check position of the tubes. About refrigeration circuit, if it's not possible to use the same refrigerant or oil, rather flush refrigeration circuit is highly recommended. You can find many of solvents for this operation at the market. So please do it. It is very important. Prepare soldering set and new filter. What more I can say? Right now, remove rubber plugs from compressor and insert the refrigeration system tubes. Also remove plastic plugs from the filter dryer and install it. Why now? Please let the compressor or dryer, let it open it shortest time as possible. Yes, as you know, polyester oil is hygroscopic, and also filter dryer silica gel is hygroscopic. So please let it open only necessary time. Then install a shredder valve to a service tube without its core. Why without its core? Its core contains some plastic part, and you will destroy during soldering. So perform soldering of all tubes of compressor, dryer, and valve. If you finish the soldering, please wait a few minutes until soldered tubes become colder. Yes. Pressurize refrigeration circuit with nitrogen. It's highly recommended to use nitrogen. And perform leakage test with soap water or a spray leak detector. In this case, you cannot use electronic leak detector because you do not have refrigerant inside. And if you are not using nitrogen with hydrogen or nitrogen with helium, I don't know that on the market exists some electronic device which react only on the nitrogen. So that's the reason why is the best solution spray leak detector. If leakage has been not observed, release the nitrogen, install shredder valve core, and start with the vacuum. If leakage has been observed, release nitrogen, fix the problematic connection, and repeat leakage test. For your information, please do not use as a vacuum pump another compressor. It is not recommended, and the compressor is not able to reach so deep vacuum as a vacuum pump. Yes. So it is really very important, and for making vacuum pumps also need some time. Yes, depends by the size. It could be from 1 to 8 hours. Yes, not just 5-10 minutes. During vacuum process, you can start with assembly of new electrical components. Yes, please always use originally supplied electrical components. Using of other or old components from previous compressor is not allowed because electrical components could be root cause of the failure of the previous compressor. So it is very important to use new components. Proper electrical diagram for each compressor model, handbook catalog, or you can find at the handbook catalog or NIDEC webpage. If the vacuum process is finished, there is a place to charge the system, yes, with the proper refrigerant. One important information, never start compressor at the vacuum. So if you decide to start compressor, you need always to have some refrigerant inside the refrigeration circuit. For example, if refrigerant quantity is less than 500 grams, charging could be performed directly to compressor service tube, yes? It means put some gas inside, 100 grams, for example, with switched off compressor, then start the system, and the rest of the refrigerant charge with the compressor turned on. If the quantity is higher, then it's better to fill the system into the liquid accumulator. Yes, for example, in this case, 2 kilograms, and start the system, and the rest, 500 grams, charge with compressor turned on. If everything is filled, please disconnect. Okay. So if everything is charged properly, there is a place for check the system performance, check if it is everything okay, check the fans, check the behavior of the system, and disconnect all devices, assembly all covers and grids. And that's all. We are on the finish. Just few recommendation on the end. Every section, every service action is different. So it is hard to quantify service action is always the same. No, each one is always different. Use only proper refrigeration spare parts. Use only refrigerant with proper quality and purity. Yes, use only proper type of compressor as a spare part, and with new compressor, use always new filter dryer also. So that's all from my side. Our time is done. So Peter, I'm giving the word to you.
Yes, thank you very much. Thank you very much, guys, both Lubor and Libor. Very good job. So now, if anybody has a question from the audience, please feel free to ask. Meanwhile, I will read. We have one question in the chat. So Mr. Rikaspi is asking, or is stating, that if a CSR can connect in a wrong way and switch between start and run, if the CSR box is horizontal, it could also cause the same burst of the start capacitor. So it's probably not too much a question. It's a statement. So Lubor, what do you say about that? Yeah. If CSR, you can connect in the wrong way and switch between start and run.
Basically, if I understood the question, someone is thinking to put this CSR box in not proper position, yeah? Lying on the side or something like that?
Yeah, the last statement is if the CSR box is horizontal, could also cause the same burst of the start capacitor.
Mm. Manufacturer is defining correct position of electrical box, and we have to follow that, because usually if there is CSR box, there is voltage starting relay which has prescribed correct position against gravitation field. And if we change position of this relay, the mechanics inside of this relay will not work properly, and it might happen that pickup and drop out values will be changed and can cause that, for example, will not disconnect in proper time start winding, or let it stay connected even forever and can burn compressor. So definitely we have to follow what is prescribed position of box by manufacturer.
So Ori is clarifying, it was comments, it was 2 comments during the lecture, that if the wires are connected wrongly to the CSR, so the start winding will burn.
Yes, obviously, because if you mix the wires and instead of run capacitor, you will connect start capacitor permanently to the power supply, he has no chance to survive it. Start capacitor by manufacturer is designed in the way that it has to be connected maximum 3 seconds and then should be disconnected from power at least 3 minutes. First condition is to avoid overheating of the start capacitor. And second is to give enough time to dissipate heat generated by function. So if we follow that recommendation, start capacitor should survive a long time. But once we connect it for longer time than 3 seconds, it become overheated and destroyed.
With CSR box, this problem could appear if you wrongly connect wires on the compressor. So usually red wire going to right and white wire to left, and black is common. If you change the red and white wire, then you will have permanently connected starting winding, and your capacitor will be burned.
And there is also one very strange combination when you mix it in, let's say, proper way. It can happen that some kind of compressor will run in opposite direction. And that's a very dangerous failure mode, because when compressor is running, there is prescribed way of rotation of the compressor to let lubrication system run properly. It means suck oil from the bottom and push through the crankshaft up. And if it's rotate in opposite direction, compressor will pump. We will not find any difference, but oil will not go up, but will be withdrawn from upper bearing, and it will break the bearing and seize them. So that's a very, let's say, strange failure mode which can appear also by mixing of the cable.
We have a new question here. How to calculate the required amount of refrigerant charge if there is no plate?
What do
So somebody is repairing a refrigerator, but there is no data plate with the refrigerant charge.
It is not possible calculate. It's a better way to contact producer for a proper charge, or install thermocouples on the inlet and outlet of the evaporator. Let the system run, and slowly each hour adding few grams of refrigerant until temperature on the evaporator will be not the same. But the best solution will be contact the producer.
Yeah, but there is a trick which we are using also in our application lab when we are testing appliances. You should apply 3 thermocouples on evaporator if it is possible, of course. If it is covered by foam, so then you are lost. But if it is visible, you can apply 3 thermocouples on the inlet to the evaporator, in the middle, and on the outlet. And by watching on those 3 temperatures, you can understand whether there is lack of refrigerant, just enough, or too much. It works in the way that if you have low temperature on the input, but in the middle and output, it's growing up temperature already, raising up, it means that you do not have enough refrigerant. If you see that you have the same temperature on the inlet and in the middle sensor, and output it's 2-3 degrees higher, then you have just correct refrigerant charge. And if you see that even on the outlet of evaporator, there is low temperature, the same like in the middle, then it means that you have flooded evaporator by refrigerant and you have to release something. So it's a very simple trick, but you need to have assembled three thermocouples, and from those data you can see it very nice, but it takes time. As told Libor, you have to charge a small charge on the beginning, measure, add, and then from data you will see where you reach the point that first two thermocouples show you the same number, and third one 2-3 degrees higher.
So the best way is contact producer.
Okay. Any more questions? There's no more questions in the chat. Please feel free to ask. Okay, if there are no further questions, we are already 8 minutes after our time zone. So thank you very much, everybody, for participation. Thank you very much, Lubor and Libor, for your time and preparation of the presentation. And we will close this session. And I hope that we will see each other sometime soon in the real Chillventa. Thank you very much.